I'm very happy to introduce our next speaker, which is Dr. Jeremy Fry from ProImmune. And he gained his Doctor of Philosophy under the supervision of Professor Catherine Wood from the University of Oxford, developing gene therapy strategies to induce immunological tolerance in transplant recipients. Jeremy joined ProImmune in 2001 to generate a new class of MHC multimer staining reagents. And for more than 20 years, he has been serving as ProImmune's Director of Sales, and he has led the sales team in a growing business, focusing on developing and implementing innovative technologies that radically improve our understanding of immune responses. And today he's going to be describing our Ankyrons, the future of target binding reagents beyond antibodies. Jeremy?
Great. Well, thank you very much, Emily, for that very kind introduction. Today we're going to be talking about our Ankyron technology. And this is going to be something that's probably very new for most of you. And as you can see from the title here, it's a fairly bold claim, but we believe that Ankyrons really are the future of target binding reagents beyond antibodies, and very much the key to your research success. Many of you will have certainly probably experienced quite considerable frustration around trying to identify antibodies against a specific target of interest. And you may have even had to pursue options of custom antibody generation. But if you've done that, you've soon come up against some pretty significant current constraints of this type of approach. It's a high risk and expensive and very time consuming venture. And with now the exponential increase of transcriptomics data that's really been driven through technologies like RNA-seq, and we've seen some really good examples of that in the symposiums to date, there's obviously a very clear need to investigate a very vast array of novel proteins, but the pedestrian nature of standard antibody generation becomes a really critically limiting factor. So just imagine, if you will, if you were able to generate target binding reagents, not to just one or two proteins at a time, but proteins against entire pathways, or perhaps your collection of drugs, your collection of biotherapeutic drugs, for example, or even against all the proteins expressed by a specific virus. This technology, Ankyrons, now enables what was really previously unimaginable to become a reality in a very rapid and cost-effective manner. So just to explain a little bit more about what Ankyrons actually are, so by way of introduction, they're 15 kilodalton proteins, approximately the 10th of the size of an antibody, and they're based on single domain ankyrin repeat scaffolds that in nature mediate high affinity protein-protein interactions. And what we do at ProImmune is to select Ankyrons in vitro that bind to a target of interest from a Terra library. So this is a library of Ankyrons that itself comprises of around 1 trillion variants. And we do that using ribosome display technology. And one of the key benefits of ribosome display is that this high diversity library can be achieved with the consequence that binders that exhibit high affinity to the target can be selected in a single pass. And this is unlike other similar approaches like phage display, which typically require more than one round of screening, including an affinity maturation step to select high affinity binders. What's also great is that Ankyrons are generated in a completely animal-free setting. So by default, our recombinant monoclonal sequences, we know exactly what they are. And because they're completely synthetic molecules, they're also not constrained by issues of immunological tolerance. And so they can be targeted against all proteins, including self-proteins. There are also no attributes that you have with antibodies such as isotypes to have to consider because they're not antibody molecules. So Ankyrons themselves are proteins that are stable and very easily produced. The single domains that we have bind to targets with high affinity, typically with nanomolar affinity down to picomolar range. So they're really as good as the best polyclonal antibody. And research applications of Ankyrons are exactly the same as that of antibodies. So they can be used in flow cytometry, ELISA, immunoprecipitation, immunohistochemistry, immunofluorescence, Westerns, cell culture, really whatever you can imagine that you're using an antibody for. And what we have done at ProImmune is just to sort of demonstrate the flexibility and the powerful nature of this technology is to launch a rapidly growing catalog that already comprises of more than 20,000 clones that target more than 1,200 proteins. And what's really unique is that we can produce any Ankyron labeled with your tag of choice. So it's almost merging the concept of a customization with catalog options, which gives you full control so that we can produce exactly what you need. So all of our Ankyrons are labeled with a whole range of different options. We can provide them with epitope tags, with biotin, with HRP, with fluorescent conjugates, which we refer to as our alpha lux range, as well as streptavidin conjugates as well. And this gives you complete and utter flexibility to apply them in the appropriate application of choice. So the other great thing is our catalog Ankyrons are available to ship in about 2 to 3 weeks from receipt of your order. And we typically have more than 6 clones available for each target. This is a completely new technology, so it was launched just a couple of months ago. And if you look at our catalog, and the link will come up in a moment in the chat, you can have a look at it directly. All the clones that we have are confirmed as being binders by sensitive immunoassay. And the definition of that is that we have a signal to noise ratio better than 10 to 1, and most actually are in more than 100,000 to 1 ratio. The other thing that I highlighted in my introduction was that, cost effectiveness is absolutely key here. So whereas, antibodies are going to be costing you several hundreds of dollars for a catalog reagent, here for just $115, you'll get up to 6 available Ankyron clones, 100 micrograms of each clone. That's equivalent to about 500 micrograms of antibody, and as standard labeled with both V5 and His tag of your preferred clone selection. So you can actually have multiple clones that you can then use in your own application. So the point of this is that you can directly, you can obviously order directly labeled Ankyrons as well and have them labeled with the different tags that I mentioned. And you can look at the specificities that we have available already on our catalog. But the catalog is really just a starting point, a springboard, just to demonstrate how quickly it is able to generate these reagents. Really what I wanted to highlight is the powerful nature of this technology, because it's going to really enable us to progress, or you to progress research ideas that have just not been realistically feasible by the approach of having to generate custom antibodies. So custom Ankyrons can be generated, and this is multiple clones for each target, in just 8 weeks from screening against the target protein. And I also just want to kind of raise up the point that these single domain Ankyrons bind with very, very high affinity. But the technology is so flexible that one can produce them not just as single domains, but we can actually daisy chain them and have multiple domains of the same specificity labeled with whatever tag you like, or indeed make them multi-specific. So this actually enables researchers that previously have never been able to order a bispecific antibody off the shelf unless it was something that had already been developed as a very kind of customized concept, literally just to order. So bispecific, multi-specific, daisy chaining of multiple domains can be generated for you at the drop of a hat. And this is what's really, really exciting, because it's going to enable you to address key questions, key research questions, and address hypotheses that just to date have not been possible. Now, one of the things in developing this technology that became apparent pretty early on is that it's all very well offering this approach, but if you don't have the target proteins to be able to screen against, that becomes very, very quickly a bit of a problem. And as you can appreciate, with the plethora of transcriptomic data coming out from RNA-seq technology, there are literally thousands and thousands of proteins that people are interested in, but they've never had them expressed. They're not available commercially. And so what we can also offer is our Ankyron X platform, or Ankyron expression platform, which will enable us to then express either the entire protein or, as appropriate, specific domains of your protein of interest to then screen against to generate Ankyrons for you. I want to really just highlight the advantage of this, because one of the key things that we can do in a state at the moment is that we're trying to build our catalog of specific key areas. And for infectious disease, of course, which is the focus of our symposium today, there are some indeed key areas that we're very keen to expand our catalog into. And this is something which we have a number of ongoing collaborations with many customers on. But if you're interested in us generating custom Ankyrons for you, and this is going to be against entire sets of proteins against key infectious diseases, whether that's bacteria, whether that's viruses, do contact us, because we'd be very keen to discuss that with you to see how we can help. So as I mentioned earlier, our Ankyrons are selected automatically from our Ankyron Terra library. and automatically selecting medium to high affinity target binding clones. We can also select precise, we can determine the precise affinities of these Ankyrons as well using solution equilibrium titration assay. And there's some example data on this particular slide here where you can see identification of some clones against PDL1 with affinities that go down to 0.7 picomolar, so incredibly low affinities. And for each target, we would aim to provide you with 6 to 10 Ankyron clones for you to screen in your appropriate assays. Now, of course, just like antibodies, Ankyrons may have slightly different characteristics. So some, if you're looking at sort of cell surface binding, may have agonism or antagonism effects, and all of these, or blocking, neutralization, all of these can be assessed using this kind of technology. And the other thing that's very important is to highlight that actually in our screening process, we can also use a guided selection approach. So what I mean by guided selection is if you're trying to, depending on your research question, if you're trying to identify Ankyrons against one protein and not another, and those two proteins are very closely related, maybe even just differ by a few amino acids, that's possible through this approach. So as long as we have the two different proteins that are related to one another, we can select all the binders that bind to one and drop all the binders and bin all the binders that don't bind to the other. Or alternatively, you may be looking for cross-reactivity. So again, we can select binders with the appropriate characteristics, just depending on your specific research question. You'll also be very aware of a keen interest that there is at the moment in the therapeutic area for generating antibodies against MHC peptide complexes, so TCR-like antibodies. And that's been very, very challenging. And I should point out that the Ankyrons, and reiterate, the Ankyrons really are for research use only. We're not talking about developing these for as clinical therapies. But generating anti-MHC peptide antibodies is incredibly challenging. And you need an awful lot of MHC peptide monomers to do immunizations in mice to then get to the point where that may even generate some antibody clones. This is actually very, very simple for Ankyron technology. And this is some example data here provided by Professor Bertoletti from Duke NUS in Singapore. We're working in an HBV setting. This is a cell line presenting peptides from HBV. You can see in the green bar there, the green histogram, cells that have been stained with an anti-MHC peptide specific Ankyron. And in the dark blue, you can see there an irrelevant peptide. So the same HLA restriction, but an irrelevant peptide. So this staining here is absolutely specific and exquisitely specific to the MHC peptide of interest. And I've just shown you some examples of our current catalog repertoire of the MHC peptide complex Ankyrons that we have here. So these are Ankyrons that bind specifically to that MHC peptide complex, which I think will be new to many of you listening. We can also make Ankyrons against anti-idiotypes as well. So you can see this is an example of data for an idiotype specific against Ankyron, against Avastin. And when we stain these against other therapeutic antibodies, you can see that it's very, very specific to the Avastin antibody. So this really enables you to access pretty much anything, as long as the target protein is a structured protein. This works particularly well for any protein that has a stable structural system. If you're talking about floppy peptides with or some sequences which are sort of transmembrane domains, obviously they can be very challenging to express. But ultimately, if you have a structured protein, then Ankyrons are ideally suited to targeting that, just like in an antibody way, except of course we can generate this very, very quickly. And it's going to enable you to drive into proteomic areas, whereas that you've never been able to do before. So if you have colleagues who are working in veterinary science, where again, reagents are very, very challenging, or you need tools against infectious diseases where you've got a whole list of potential target proteins and you just don't have the reagents and the tools against it, then do have a chat with us, because we can work with you and we can generate these for you. So just to summarize, the Ankyrons are small molecules. They're 15 kilodaltons in size, so a tenth the size of antibodies. We do this single direct selection from our Terra library, which makes it very, very quick. They're not species dependent because it's a completely in vitro approach. And the stability of these proteins are very, very high. They are heat stable. They bind directly to the targets of interest very, very simply. And they're very, very easy to engineer as well. So we can put them together as multi-specific and with tags as interested as you are. We can customize them in any particular way, as I've already described, and they can be available with very, very high affinity. So that's just a brief introduction to the Ankyrons technology. There's going to be obviously more and more data coming out as these molecules are published, but do have a look at our catalog, because you'll see there the range of molecules. This is obviously just beyond thinking about purely immunology, but certainly the audience here will be very interested, I think, in some of those key molecules. So I would like to just open the floor for any questions, and thank you very much for your time listening to me today.
Great, thank you, Jeremy, for that introduction to the Ankyrons. Are there any questions from the audience? Everyone's already thinking about how they can work it into their...
Yeah, Stephen, you have a question.
Yes, Jeremy, I think you just touched upon that briefly, but can I just check, can you generate Ankyrons specific to whole cells, or, can you use a whole cell as something you can pan against or look for reactivity against?
Not really, no. So it has to be a defined protein, or a defined domain of a protein to be able to, that can be expressed and then screened against. So it's not going to be against a whole cell.
Okay.
To generate them in the first place. Obviously, once you've generated them, then you can use them against cells. But yeah, the screening process requires specific proteins,
right,
or domains. Yeah.
Great.
Often, I mean, again, having had many of these sorts of discussions with lots of people, sometimes this kind of concept may take a while to filter down and sink in, because it's quite a game changer in how you could potentially address some key research questions, which just hasn't been possible before. But I do want to just highlight the fact that the throughput of this kind of system is enormous. And so whereby in the past, these have just not been possible, I would encourage you to contact us, because we're able to enter into this sort of approach where even if you have a bucket list of proteins, and that bucket list of proteins is like 100 long, we can make those proteins, and we can screen them, and we can generate Ankyrons for them, even if you're only going to probably have the ability to screen Ankyrons against 6 or 10 of those targets, because obviously each one is a lot of work to then characterize and qualify in detail. Ultimately, we can get on with that behind the scenes. So from a point of view of just making these tools accessible to the broader community, it's very, very exciting.
Thanks very much.
Jeremy, there's a question in the chat.
Great, let me have a look at that. Sorry, I missed that. Oh yeah, so Pete asks, apologies, wondering if Ankyron-bound cell receptors generate downstream signaling. So yes, Pete, exactly the same as in an antibody situation, that could be the case. So if it binds to a particular receptor, whether that's like a T-cell receptor, CD3, something like that, then of course you could induce signaling. So that would just have to be characterized based on the individual clones, and the way that they bind would potentially vary quite considerably. So, but technically that can indeed be done.
Okay, thanks, Jeremy.
Thank you.